Chemistry. This lesson will give you an idea of why the periodic table has the shape that it does and how it's structured, and this is called building the atom. So the rows in the periodic table are called periods, although I usually just call them rows, and the columns are called groups. So each period represents a new orbital. We talked about what an orbital is. It's an energy level that atoms have, and they have a variety of them. They have several of them. So the first row represents the first orbital. These are the electrons that are closest to the nucleus. The second row represents the second orbital, the third row, the third orbital, and so forth all the way down to the bottom. Each group, that is each column, represents an additional valence electron. Remember, valence electrons are the electrons in the outermost shell. Those are the ones that get involved in chemical bonding, so they're the most important. So the first column represents one valence electron. So hydrogen, for example, has one orbital, and it has one electron in that orbital. Lithium, if we go down, has two orbitals. So the second orbital is its valence orbital, and it has one valence electron in its valence orbital. If we go down another, you'll see sodium, Na, has three orbitals, and it has one electron in its third orbital, its valence orbital, and so on down. If we go over to the next column, beryllium, we see, has two orbitals, and it has two electrons in its second orbital, its valence orbital. Magnesium down below has three orbitals, and it also has two electrons in its valence orbital, which is the third orbital. And so you see that same pattern will go all the way across. We skip over the transition metals. I call that the valley in the middle of the periodic table. They do not contribute valence electrons. But over to boron and the elements down below it, they have three electrons in their valence orbitals. Carbon has four, and the elements below it have four. Nitrogen and the elements below have five. Oxygen and the elements below have six. Fluorine and the elements below have seven. And the noble gases, the very last column, they have eight. They have a full valence orbital. And we will see how that provides stability for atoms and why atoms want to be like noble gases. Okay, so let's go ahead and build an atom. We're going to build a silicon atom, and if you look at your periodic table, you will see the entry that you see in the upper left. Silicon, symbol Si, has an atomic number of 14. That means it has 14 protons. And at the time it's created, it also has 14 electrons. All atoms have the same number of protons and electrons when they're created. It has an atomic mass of 28.09. And so we're going to round that number in a minute, and I'll explain why that is. You'll understand that at a later time, but we're going to do that. Okay, so here we go. What we're going to do is keep a scoreboard of how many protons silicon has, how many electrons, neutrons, how many orbitals, and how many are valence electrons, because remember, those are the most important electrons. And then we're going to draw a diagram in the lower right. So you see the rectangular box that says protons and neutrons. That's going to be the nucleus. And then we're going to put orbitals around that and then place the electrons. So you'll actually draw a diagram of a silicon atom. So here goes. Let's get started. So silicon has an atomic number of 14. So it has 14 protons and 14 electrons. And so we're going to go ahead and fill in the scoreboard there with 14 protons and 14 electrons. Those two numbers are always going to be the same in an electrically neutral atom, and that's all we're dealing with here. Okay, and we're also going to place the 14 in the nucleus in our diagram. Rather than draw 14 circles with plus signs, which is kind of tedious, we're just going to write 14 protons. Okay, next step. There's the electrons. Now we're not going to place them right away, but we're going to put them off to the side. So if you count them, there's 14 electrons. Now we go on to the next step. Now we round the atomic mass to the nearest whole number. This is the mass of the most common isotope of silicon. So it's a mass number. I won't get into that detail right now, but it is the most common isotope of silicon, would be silicon Si-28. So we're going to go ahead and watch that over there on the left, and we're going to change that to a 28. Okay. All right, now we move on. So now what we need to do is figure out how many neutrons this silicon atom has. Okay, so we can now calculate the number of neutrons by subtracting the atomic number, which is the number of protons, from the mass number, which is the total number of protons and neutrons in that isotope. So it's just a simple subtraction problem. So mass number, protons and neutrons, is 28, the number we have over there on the left. The atomic number we get off the periodic table is 14. That's the number of protons. So if we subtract those, it will give us the number of neutrons. So we go ahead and do that, and we end up with 14 neutrons. Okay? It happens in silicon's case, it's the same number of protons and neutrons, but that's not always true for all elements. So we're now going to go ahead and place the 14 over here in our scoreboard, and we're also going to place it in our nucleus for our diagram. So 14 and 14. Alright, because silicon is in the third period row, that means it has 3 orbitals. So there we go. Everything that's being covered over in green is in the third row, and all of those elements, the atoms of all of those elements, have 3 orbitals. Third row, 3 orbitals. So we're going to go ahead and put that in our scoreboard, and we have orbitals 3. We're also going to bring them in on our diagram. So there's the first orbital, there is the second, and there is the third. Okay, so we've now placed our orbitals. Next, we now place the electrons. The first orbital gets 2 electrons, then it's full. The second orbital gets 8 electrons, then it's full. The final 4 electrons go in the outer orbital, and they are spread out. So you know how many electrons an orbital can take by how many elements are in the row. So the first row has just 2 elements, hydrogen and helium. So it can take 2 electrons, the first orbital. The second orbital has 8 elements, the second row, and so that orbital can take 8 electrons, and everyone down from the second row on down can take 8 electrons in its valence orbital. So here we go. So there goes the first one. Now I'm going to draw these in a very specific order, and I'd like you to do it the same way, okay? So we're going to put the first one there, and then the second one there. Now there's the 2 electrons that the first orbital can hold. And I like to put them side by side, unlike a lot of books. I put them side by side because when 2 electrons are side by side, it means they cannot bond with another electron. And that's a detail we'll get into later. So I put them side by side. Now here we go to the second orbital. Okay, and by the way, that one has no vacancy. You cannot fit any more electrons there. Now we're going to go to the second, and we're going to place 1 there. We're going to place 1 here. We're going to place 1 up here, and you place 1 up here. Notice these are negative charges, so they want to spread out. If you go into a movie theater and you sit down and someone else comes in that you don't know, they're not going to sit right next to you. And another person comes in, they're not going to sit right next to you. You're going to spread out all over the theater. But then the theater is going to start to get crowded, and you're going to have to sit next to other people. So we're then going to put the 5th electron there next to this one, and next to this one, there, and there. I would like you to mimic this exact pattern that I just drew these electrons in, okay, when you do this, okay? Now the second orbital has 8 electrons. That's all it can hold, so it has no vacancy. So now we're going down to the third orbital, and we're going to place an electron there, an electron there, an electron there, and there, okay? And that's all the electrons. Now, the number of valence electrons is 4, but sometimes that's all you want to know is how many valence electrons without drawing this diagram. So the way you can do that is we know that silicon has 4 valence electrons because it is the 4th element in its row. You'll notice in this diagram of the periodic table up top, I eliminated the transition metals. So I closed up that gap that the transition metals would have spread out, beryllium and boron, for example. They would have separated. Okay, so here we go. All right. So there's number 1 is sodium, number 2 is magnesium, number 3 is aluminum, and number 4 is silicon. So that's how you know that silicon has 4 valence electrons without having to draw this entire diagram. And we're going to go ahead and fill in our scoreboard down there, and that completes our diagram for silicon. Okay, so that's how you diagram an atom, and we'll practice that in class. Alright, so we'll practice some of these when you get your assignment, and you'll do one on your pre-assignment.